Let's look at question number 9. So, consider a closed economy in which an individual's labor supply to firms is determined by the uh, amount which maximizes her utility function. Utility equals to C to power alpha 1 minus L to power beta. So, let me just write it down. Utility equals to C to power alpha and 1 minus L, which is basically the amount of leisure to the power beta. C is the consumption expenditure, which is taken to be equal to WL. Alright, so C is equals to WL. So this gives utility as a function of a single variable WL times alpha into 1 minus L times beta. Okay, so you can write this function as utility equals to W to power alpha into L to power alpha into 1 minus L to the power beta. So W to power alpha is common, so you can do a monotonic transformation on this function and represent a new function v, which is u to the power u upon W to the power alpha, which is going to be L to power alpha into 1 minus L to power beta. Okay, now I can do maximization of v instead of maximizing u because it's just a monotonic transformation of u. So maximizing u with respect to L has the same solution which has maximizing v with respect to L. So I'll just do dv by dl. This would be alpha L to the power alpha minus 1 into 1 minus L to the power beta minus L to power alpha into 1 minus beta times L to power alpha into 1 minus L to the power beta minus 1. Okay, so at optima this has to be equal to 0. So I can basically substitute this thing equal to this thing. Okay, थोड़ा better लिख देते हैं इसको, equals to beta times this implies so this goes here and it will become L, so this will become alpha times 1 minus L is equals to beta times L. So we get 1 minus L is equals to beta upon alpha times L. So this says alpha plus beta upon alpha times L is equals to 1, which implies L equals to alpha upon alpha plus beta. Okay, so this is the optimum amount of labor supply which is going to be provided, and as you can see this is independent of W, so you can just write it down that the amount of labor supplied is independent of W. All right.